This application we're going to see is mortgages. So say I borrow $1 million at 5% per year for 25 years, and it's compounded. You know what, I'm just going to make it 6 actually. 6% per year compounded monthly. Right. So that means that the interest monthly, the period is month, so therefore, and so the interest is 0.5% per month, because I divide by 12. That makes calculations a bit easier. And I would like to know what is the monthly payment. Right, let's call this monthly payment P. Right. So what's the situation? So at the beginning of the loan, that's the loan that the bank give me, basically. Yeah. My debt, which I'm going to call debt at 0, is equal to $1 million. Now, after 1 month, my debt. After 1 month, the debt is, okay, so it's D1, and D1 is what? Well, the $1 million that I had in debt has accumulated interest, so it's $1 million times, well, the monthly interest, so it's 1.005. So now my debt has increased. However, at the end of month 1, I make my first payment P, so I need to subtract my first payment P. Right. So after 2 months, the debt is what? D2. And D2 is, well, the debt that I had at end of month 1, which has now accumulated again interest, so it's 1.005. But then I'm making a new payment, which is payment P. So, okay, so I can maybe simplify a bit this expression. So D2 is equal to D1, that's $1 million, times 1.005 minus P, times 1.005 minus P. And so, okay, so let's reorganize that a little bit. So that's equal to $1 million times 1.005 square minus P times 1.005 minus P, which I can reorganize a little bit as 1 million times 1.005 square minus P times 1 plus 1.005. Okay, that was the end of month 2. Now at the end of month 3. After 3 months, the debt is, okay, so it's D3, so it's calculated from D2, with the debt that I had at the month before, so it's D2 times 1.005, and then minus P, the payment that I've done. So, okay, so I can simplify that a little bit. Now, from now, you probably wonder, oh, this is getting long and looks very complex calculation. Yeah, it looks like it, but actually it's going to simplify massively. So D2, 1 million times 1.005 square minus P times 1 plus 1.005 times 1.005 minus b, which I can simplify as, I'm going to go a bit faster here, cube minus b 1 plus 1.005 plus 1.005 square. Right. Okay, well, you can see that there is a pattern here, from here to this one, and even this one. The pattern is that at the end of month n, the debt is going to be dn 1 million 1.005 power of n minus p 1 plus 1.005 plus up to 1.005 power of n minus 1. Now this we can simplify a bit because it's a geometric series and it can be written as 1.05 power of n minus 1 over 1.005 minus 1. Right, so let's rewrite dn a bit. dn, therefore, it's 1 million times 1.005 power of n minus p times 1.005 power of n minus 1 over 0.005. Right. Well, at the very end, when I make the last payment, my debt is what? 0. Yeah, because I finished repayment. So that means that we are looking for n such as 0 at the very end is equal to 1 million times 1.005 power of n minus p and actually, sorry, at the very end, I should say n equal what? N equal 25 times 12, which is 25 times 12, 300. So that means that n is equal to 300 times 1.005 power of 300 minus 1 over 0.05. So therefore, P is equal to 1 million times 1.005 power of 400 times 0.05 over 1.005 power of 300 minus 1, which if I plug that in the calculator, 1.005 power of 300 minus 1 so there's a 0 here, times 1.005 power of 300 times 1,000 not times a million. What am I doing? Yep, so it's $6,443.01, and this is the monthly repayment. There you go. So that's the interesting thing here. To find this monthly repayment, we just need to realize that at the very end, when I make the last payment after 25 years, my debt is 0. And to arrive to that, I have to make a payment of $6,343 every month. Now, how much interest have I paid in total? How much have I paid in total? Well, easy. I've made total. I've made 300 payments at $6,043. So that means that I paid in total 1.932904. Knowing that I have borrowed only 1 million, so that means that total amount of interest I paid is $932,904, which is a lot. Basically, it's almost as much as the value of the place that I bought. Right, let's do another kind of calculation. Annuity. So say I won the lottery and I won $2 million. And I want to live off that for 20 years. And this is placed in an account that brings 5% per year. And I'd like to know how much I can take every year out of this $2 million. So basically, okay, how much do I have left at the beginning? How much do I have left at the beginning of year 1? Well, easy, the $2 million. This I haven't withdrawn yet. Now, how much do I have left at the beginning of year 2? Well, I have $2 million. Let's call that left, and then 2. So I have $2 million. Times, well, it has accumulated interest, so it's 1.05. And then minus the money that I got, which is, say, that I took to enjoy my life. And so, okay, so it's L2 is 2 million times 1.05 minus P. How much do I have at the beginning of year 3? Well, so what I left is I have, well, the money that I had left at the beginning of year 2, which is L2, which has now accumulated interest, so it's accumulated 1.05 interest, minus the payments that I took. And so, okay, well, so I can simplify that. L3 is 2 million times 1.05 minus P times 1.05 minus P, which I can simplify that a little bit. 2 million times 1.05 square minus P 1 plus 1.05. Now, again, you see a pattern. It's not too difficult to realize, though, how much do I have left at the beginning of year 20, year 20. Well, I have L20, which is 2 million, times 1.05 power of 19 minus P times 1 plus 1.05 plus dot, and this time it's going to be 1.05 power of 18. Right. but L20, after 20 years, there is nothing left, so it's equal to 0. So, okay, so therefore I know how much, from this equation, I know that I can calculate P. And this is equal to what? This is equal to 1.05 power of 19 minus 1 over 1.05 minus 1. Okay, so therefore P times 1.05 power of 19 minus 1 over 0.05 is equal to 2 million times 1.05 power of 19, and so therefore P is equal to 2 million times 1.05 power of 19 times 0.05 over 1.05 power of 19 minus 1, which is equal to well, so therefore I can pay myself 165,490 per year. There you go, that's the payment that I can make. And over 20 years, how much money that would be? Well, easy, we times that by 20. So basically, we have given ourselves 3,309,800. So we made interest of 1.3 million approx out of the 2 million over 20 years. This is an application of the series to financial math.